Hola, mi clase. All right, we are going to review some radicals. So mainly the thing is that we can prime factorize so that we can simplify radicals. So radicals, basically, first thing, square root is a number that is a result of multiplying an integer by itself, right? So if I ask you for the square root of 4, we would say, well, we could do 2 times 2, or we could do negative 2 times negative 2. So then our answers are 2 and negative 2, right? So that's perfect squares, right? Where it's like, oh, integer, going to be always the same thing. Now, a radical is what we call these symbols. So it's a symbol that represents the root of a number, such as square root, cube root, fourth root. So this symbol right here is called a radical. It takes care of all of that. All right, and we can put that here too, right? Square root, cube root, fourth root. And then prime factorization is the process of writing all numbers as a product of primes. So if we take the number 10, we can say 2 times 5. That wasn't a really good example. So we would say it's 2 and 5. If I take a bigger number like 24, right, that's 4 times 6, 2 times 2, 2 times 3. And so we would say 2 to the third times 3. Okay, so that's that prime factorization. All right, so we're going to find the solution for x. And as we know that when we have x squared equals 49, we know that the inverse of squaring something is square rooting something. So we're going to square root both sides, and we were going to say x equals, and if you notice on the very first slide when I talked about perfect squares, I gave you 2 answers. I said positive and negative. So we can write this 2 ways. We can say 7 comma negative 7. But another way you're going to see it written is like this. You write plus minus 7. Either one of these are okay. I will say that this is kind of the most common way, but this way will come up when we're talking about like solutions for quadratics. That's kind of why we're talking about this, so that we can review this, because it's going to connect to quadratics. So just as a quicker version, these are all quick. So square root, I've typed that wrong. We'll see. Sorry. Sidetracked. I would say x equals plus or minus 15. All right, you guys are going to get calculators to be able to check these things and find out what they are, but it's the important part is understanding that when we do this, we get 9 or negative 9, right? Plus or minus 9. The main part I'm trying to get out of this is that when we square root both sides, we do not get one answer. We get 19 and then, right, so we get plus or minus 19. So that's the whole main point of that. Just understanding that when we square root, we get 2 answers. And this is going to connect, obviously, to quadratics, because when we were doing quadratics, we were getting 2 answers. The part that where they cross at that x-axis. All right, so now we're going to work on prime factorization, so that we can, what we're going to do with these is going to come up when we talk about simplifying them. So yeah, I know I picked some crazy numbers, but that's okay. So easiest one here would be like 27 and 100, right? 27 times 100 would definitely get me 2,700. But neither one of these are primes. So this is, 9 times 3, and this is 10 times 10. And then this we have to separate as 3 times 3. And then now we have to separate this 2 times 5, and we have to separate this 2 times 5. Now everything is in prime form. Now, if you forgot what a prime is, just to bring that up, a prime is a number that only multiplies by itself and 1. Those are the only factors it has, 1 and itself. Alrighty, so now if we write this in prime factorization form, we would say 3 cubed, because I got 3 3's, times 2 squared, because I've got 2 of those, and then times 5 squared. Okay. I will do this one again. So 16 times 100, we get 4 times 4. 10 times 10, we get 2 times 2. 2 times 2, 2 times 5, I should know this, we just did this one, 2 times 5. So now I've got tons of 2s, so 1, 2, 3, 4, 5, 6, so 2 to the 6th times 5 to the 2nd. All right, that's where prime factorization comes in. So now we're going to simplify these radicals. So we have the square root of 81 over 16. I cannot reduce or divide 81 by 16. If you put in your calculator, it comes out as crazy decimal 5.0625, right? I'm not going to then go square root that and figure out what it is, but I can do it in a little simpler way. What you actually can do when we have radicals like this, you can separate these into 2 pieces, right? So these numbers right now are not prime, but we call them, as we've heard this term, we call them relatively prime, because once they're together, I can't reduce them, right? We know that 81 and 16 is not prime, but once they're together, I have to consider them relatively prime. But now I can reduce these. I know that I can get 9 and 4, but we also know, like we just talked about on the very first page, I can get the opposites of these, and so I end up with negative 9 over 4, okay? And I know you're like, wait, but about negative 4. Well, if I take negative 9 over negative 4, I just get 9 over 4, which I already got here. So what we get is plus or minus 9/4. This is the other easy way you could write it, right? Just like we did on the other one, plus or minus 9 over 4. Same idea, right? If I take 9 over negative 4, that just gets me this one. So every single time I'm going to get a positive version and I'm going to get a negative version. So we can just say plus or minus 9 over 4. All right, this is not number 2. That's actually, it is number 2, but this is actually telling me to take 2 times the radical or the square root of 100 over 64. So I'm going to do the same thing I did here. I'm going to separate this first and do 100 over the square root of 64. I'm going to get 10 over 8. Now, could I have reduced 100 over 64? Yeah, but it's a little easier to reduce 10 over 8. So I would rather do that. So I get plus or minus, because always it's a radical, so I get opposite. I get 5 over 4. But what this was telling me was to now multiply that by 2. So we're going to separate this kind of into 2 problems. I'm going to take 2 times the positive version of 5 over 4. I'm going to take 2 times the negative version of 5 over 4. So we get 10 over 4. And we get negative 10 over 4. And there's my 2 answers. So you can see I still get 2 answers. We could write plus or minus 10 over 4. It's another way we could say it. But I just want to point out that that's what that 2 on the outside is saying. It's like, hey, first we have to do this radical, because radicals or square roots are part of the exponent family. Exponents come before multiplying. So I have to first simplify that part, then I can do my multiplication. So we're going to do the same thing here, right? So there's my multiplication. I'm going to take the square root of 36 over the square root of 49. I'm going to get 6 and 7, but I'm going to take negative 3 and times it by the 2 versions, right? Plus or minus. Now, you can separate them like this if it makes it more sense to you, which I'm going to do. So I'm going to go negative 3 times positive 6 over 7. I get negative 18 over 7. And then I'm going to take negative 3 and take the opposite, the second version of that. And I'm going to get positive 18 over 7. Okay? Now, in this case, we do keep getting the plus or minus version, right? But it is important to understand that it is 2 problems. Just like when we were factoring quadratics, I set them out and then we solved them. I set them up as 2 separate problems, right? X plus 2 equals 0 and X minus 5 equals 0. And then I solve them. So that's kind of the same thing I'm doing here, right? These are my 2 problems, right? So let me erase those so you don't think they're a bunch of negatives. Okay. There we go. All right. We are going to simplify these radicals, but we're going to do it a little, it's not as much as you think yet. I'm just going to kind of combine now that prime factorization. So you're probably like, why are we even prime factoring? It's so that we can then break up these square roots and break them out into what we call simplifying square roots. So I need to break up 32 into prime factors so that maybe then I can square root some and not square root all, right? So if I take the factors of 32, what is that, 8 and, I can't think right now, 8 and 4, I got it, 8 and 4. So I can say this is the square root of 8 times 4. All right, so then I can break up 8. Well, that's the square root of 4 times 2 times 4. Okay. I can continue, but if you notice, I start seeing some pairs. And so I can break it up like this. I can go 2 times 2 times 2 times 2 times 2. And so I broke up the 4 to this set of 2's, and I broke up the 4 into those set of 2's. So we're doing this because we want to simplify this radical. So square root is numbers that have been multiplied together, right? Pairs. So I can then break this up like this. Well, here's one pair. Here's another pair. And then I'm left with this pair. Okay? Another way I can write this is the square root of 4 times the square root of 4 times the square root of 2. And right now this doesn't make any sense because you're like, why am I doing all this? Well, we need to practice simplifying these radicals or these square roots because when we go into our next unit, it'll make a little more sense. But I want to just kind of pre-prep you for the process of doing so, okay? We do this because then look, I can take this square root of 4. I know what the square root of 4 is. It's 2, but it's plus or minus 2, right? And then this one's plus or minus 2. And then we have this one that can't be broken up, okay? So we do this so that maybe we can pull out some pairs. And so I'm going to just leave it like this for now because I think if I continue, it'll kind of confuse you for your next module or your next notes, which is 9.3. But I just wanted you to kind of start seeing the process of why we even simplify them and why prime factorization comes in, right? So let's do 150. Okay, this time I broke it all the way down into primes. Maybe this time I won't. So I can do 15 times 10. Okay, I'm trying to find pairs. I don't have a pair yet, so I'm going to go square root of 5 times 3 times 2 times 5. Well, now I have a pair. I can use the commutative property to get them next to each other. So I'm going to write it like this, 5 times 3 times 2. Now I'm going to split it off just like I did here because I now have pairs. So I'm going to go square root of 5 times 5 times the square root of 3 times 2. Okay. Same thing, square root of 25 times the square root of 5. And then if I wanted to, I could say, hey, plus or minus 5 times the square root of 5. Okay, and that's where I'm going to stop. That's as much as I can clean up anyways. But again, I'll explain like this whole, like what do I do with these plus or minus here. But I just want you to get the idea of finding those pairs so that you learn how to break them down. Okay. All right. So for 252, it might be a little harder for you to know, like, what can I even divide that by? 5, 6, 7, 8, 9. I don't know if you guys know the rules of threes, but if you add these together, 5, 6, 7, 8, 9, that means you can automatically divide by 3. You are going to get a calculator, so you can use all sorts of things. So like for me, I'm like, oh, I know that's even. So I'm going to go 2 times. I'm going to use my calculator, and it's 126. Well, I now know that's even. So I'm going to go square root of 2 times, times 2 times 63, right? This is this 2, and that's that 160 or 126, okay? There we go. I now know that 63 is 9 times 7, okay? I can combine these 2's if I want right now, and I'll show you why here in a second. So this is similar to over here, this first one. I didn't have to separate these 4's, but I could. So now I'm going to separate this. I'm going to go times 4 times 9 times the square root of 7. I'm going to break them all up. That's because I know that this is 2. I know this is 3. And I'm going to leave this as this. Okay. So that's the basics of how to simplify radicals and why prime factorization comes into that, because I have to be able to break these numbers down into these pairs that I can then simplify to whole numbers or integers, okay? So that's the basic. It'll make more sense when we get into 9.3, but we needed to kind of like review prime factorization, what's a radical, how can I split them apart and move them around. So you could see, you know, in this version, I was able to split them apart into 2 separate fractions and then do my multiplying. In this version, you split them up inside of them, but then you can also separate them as separate square roots. So I just want to show you that because that'll make help with 9.3 a little bit, okay? All right, so I guess our main thing to remember is that when simplifying radicals, we're trying to find perfect squares or those pairs, right? So simplifying, did I spell that right? Simplify, nope. Oop, that's an I, that's Wi-Fi-ing radicals. Guys, I can't spell today. Radicals equals find perfect squares or pairs. Okay, so that's the whole point of it, right? Okay, so then your independent practice is to practice one from the additional practice, right? Like this. So I want to see answers that are circled, similar to the answers I circled. And then you're going to practice one that's like this. And you can totally leave it for now because this will, again, we'll grow on this, or I should say build on this, probably should be the word, on these types of answers. These are going to be my final answers. These types of answers at the end, okay? So just, that's it for now. Don't worry about, you know, understanding like now what do I do with this plus or minus? We'll talk about that more in 9.3. I just kind of wanted to have you guys understand how you could break up radicals to clean them up and, in a sense, simplify them. All right. Until next time, adios.